you guys are getting. Okay. Yep. No, lunch. We have a lunch from 11:05 to 11:30. So class doesn't start till 11:30.
So, like, what time is she?
So,
Because she didn't leave
yeah.
anything.
Okay.
Miss Rapovo.
That's okay. So if you come in here from 11:30 to like 12:05, and then you go to Sherman's class from 12:05 to like 1.
Thank you.
You're welcome. Perfect. Thank you, sir. Okay. A sequence is a function whose domain is the subset of natural numbers. So remember, this is our journal. This is what helps us when we take our test, right? This is kind of our reminder idea. So the first term of this sequence, called A of 1 or A sub 1, is what? What is the first term of this sequence pictured here? 4, 10, 16, 22. What is the first term? 4. The first term is 4. It's the first number in the list. It says, what is the common difference? Or the common difference is, and the common difference is. That means, what am I adding or subtracting each time to get the next guy? Add 6. So I'm going to write that my common difference is plus 6. My common difference is plus 6. Exceptional. Okay. That's it for the front page. The front page is just kind of a reminder of what a sequence is. I put a definition there. It says a sequence, a discrete linear function. Discrete means that it's only points. I'm going to add that up there. The word discrete means, right, it's just going to be the points. We don't connect it with a line, just the points. The terms in the list increase or decrease by the same amount. It's called a common difference. Okay. So an arithmetic sequence is given by this recursive definition. A of 1 equals 12, and A of n equals A of n minus 1 plus 4. What are the first 6 terms? All right, Delilah, we've been working with sequences this is our 3rd day now. Tell me what the first term is of that sequence, and how do you know? Yeah, how do you know that? Perfect. It says A of 1 is 12. Excellent job. Tayana, tell me what that recursive definition, A of n equals A of n minus 1 plus 4, tells me to do. If I want to find the next term, what do I have to do? Add 4 to the previous. So I'm going to take this 12 and I have to add 4 to it. What is 12 plus 4? Okay, and we're just going to keep repeating that pattern. So what's 16 plus 4? And what's 20 plus 4? And what's 24 plus 4? And what's 28 plus 4? And we only needed the first 6 terms, right? We only needed the first 6 terms, okay? Number 2, it says, write the recursive definition for the table. I'll make copies of all this stuff. Thank you so much, Mr. Reynolds. I appreciate it. Write the recursive definition for the table. So recursive definition, the most important thing I have is the initial value or the starting number. What is my first term? -8. So B, I'm going to write it as a function this time. B of 1 equals -8. B of 1 equals -8. Noah, you got your head down? Or are you working with me, bud? How can you see that? Are you okay to see that? Yeah. Okay. What about what's happening each time? This kind of looks like a slope table, if you ask me. This kind of looks like a slope table, right? Like when we would calculate slope. What's happening on the y side? What am I doing every time to get to the next term? I'm adding something because they're getting closer to 0. Yeah, I'm adding 2.5 plus 2.5 each time. Okay, so let's see. B of n equals B of the previous term, n minus 1. And what am I adding each time, Hayden? Plus 2.5. That is my recursive definition. So I need both those pieces. I need to have this, and I need to have this. Those are the 2 pieces that define this equation recursively. Okay? and I even kind of wrote a little definition here, and I just want to remind you, remember that a recursive definition is, or a recursive sequence is, or recursive formula, sorry. Recursive formula is the term in each sequence depends on the one that came before it. So when we talk about this n minus 1, it's just saying if you're looking for the nth term, you need to find the one that came before it first. That's what that recursive means, okay? Next one, example 3 says, consider the arithmetic sequence whose first 3 terms are -16, -9, and -2. What is the fourth term? Say that again. Would it be 5? What am I doing each time, Jaden? Yeah, I'm adding 7 each time. So this is 5, and I'm adding 7. The question that says, what is the common difference? What am I going to put there? 7. Yeah, I'm adding 7. So the difference is 7 each time. There's a difference of 7. Write the recursive formula for A of n based on the term number n. So what do I need to start with, Carla? Recursive formula. What's the most important thing? Start with what? The what term? Look at me. The what term? The first term. I need to know what A sub 1 is. What is the first term in that sequence, Carla? -16. And then I say, okay, that's like the first term. Now, the recursive formula, A of n, the next term is, equals means is the, sorry, I made my parentheses too big, is the previous term, and I show that by A of n minus 1 plus 7. So if I want to find the next term, I have to take the previous term and add 7. Okay. So then it asks me about the explicit formula. And I wrote kind of like the master of the explicit formula right here. That's kind of like the key. Every time you need to write the explicit formula, it's going to look like that. So it says, write the explicit formula for A of n. So we're just going to kind of model this. A of n equals, okay, let's see. What this says, I need A of 1 or A sub 1. What is the first term again? -16 plus D is my common difference. What is my common difference? 7 times the parenthesis n minus 1. That stands for my previous term. Parenthesis n minus 1. That stands for my previous term. Do you guys remember yesterday I said you can take an explicit formula and put it into what form? Because this is a linear function. How can we turn an explicit formula into what? Do you guys remember? I'm going to shrink this up and show you. Remember I said that an explicit formula can be written in the form y equals mx plus b? So let's look at that. If I take this A of n, which is my output, same thing as y, equals -16 plus 7 times n minus 1. Let's see if we can't simplify that. Let's see if we can't simplify that. What do I need to do with this 7 that's outside my parenthesis? If I want to try and simplify this, I have to distribute it. So A of n equals -16 plus, sorry, 7n minus 7. Can I combine any like terms? Yeah, I can take -16 and -7 and add them together, and that gives me -23 plus 7n. Is this written in terms of slope-intercept form? Really close. I just want to change the order, right? A of n equals 7n minus 23. This models this. Okay. We just did that by taking the recursive or the explicit formula that we wrote, and we just made it look like that. Okay. All right. So why do we use the explicit formula? The explicit formula is so important when we have to find some weird number of term, like the 30th term or the 50th term. We don't want to have to keep repeating that pattern, +7, +7, +7, +7, 105 times. That would be absolutely ridiculous. Okay. Even if you were using a calculator. That's why we have the explicit formula. So I wrote here, in an explicit arithmetic sequence, terms can be found without the use of the previous term. This form allows you to find the nth term of the sequence. That's why this form is important. It's important to know how to use it. Okay. Question number 4 is a little crazy. It says, hey, this is a finite term or a finite sequence, meaning that it has just a set number. So the number of terms in my sequence, well, the first term is 5 and the last term is 61. And what am I doing to get each term? What am I doing to get each term? Like, what did I do to 5 to get the next term? Yeah, so a sub 1 is 5, and my common difference is 8. So I can actually use this explicit formula to figure out how many terms, how many numbers are in this sequence. So we have everything we need. This is my total output. This A of n is my output. This is saying the last, like whatever number you want. Well, this is the last number in my sequence. So I'm going to start with that. It's my output. So I'm going to say my output is 61. And that equals my first term, a sub 1, which is 5, plus d, my common difference, which is 8, times n minus 1. And I have to solve it to find n, because n is the number of terms. I have to solve it to find out how many terms are in the sequence. How am I going to solve this equation? Well, first thing I'm going to do is distribute. So let's see, that gives me 61 equals 5 plus 8n minus 8. 5 minus 8 is what? So 61 equals negative 3 plus 8n. What happens when I take 61 and I subtract 3 from it? Or add 3 to both sides. 64 equals 8n. How many terms are in my sequence? Yeah, n equals 8. N equals 8. There are 8 terms. 8 terms in this sequence. You could just repeat the pattern, plus 8, plus 8, plus 8, plus 8, plus 8, until you get to the last term. But it's easier to do it this way, okay? Number 5. Number 5. Consider this sequence whose first 3 terms are given by negative 2.4, positive 1.2, positive 4.8. What is the 4th term? God bless you. Well, the first thing I have to do is figure out what I'm adding each time. What am I adding each time? What is my common difference? It's 3.6. I'm adding 3.6 each time. So the 4th term is what? What is 4.8 plus 3.6? The 4th term is, I think it's 8.4. Is someone doing that math? Okay, 8.4. It says, write the recursive formula for a of n. Well, I have to start with my first term, a sub 1 equals negative 2.4. A of n equals my previous term, a of n minus 1, plus what am I adding each time? 3.6. Write the explicit formula. Write the explicit formula. So that's in the top, like the top right. I highlighted that for us, right, to do the last question. So remember, my explicit formula, a of n, starts with what is my first term? Negative 2.4 plus d. What is the value of d? My common difference. 3.6 times n minus 1. So this is how you use it to find the nth term. We don't want to keep adding 3.6 32 times. That would be absolutely ridiculous. So what do? Well, instead of using A of n, we're going to use A of 32. We want to find the 32nd term. Well, I'm just going to plug it into this equation. Well, that means I have negative 2.4 plus 3.6 times 32 minus 1. Well, what is 32 minus 1? It's 31. So A of 32, the 32nd term, is negative 2.4 plus 3.6 times 31. Who is calculating that for me? Negative 2.4 plus 3.6 times 31. What do we get? 111.6? I don't think that's what I got when I did it. That's what I got. I got 109.2. I don't think you put a negative in front of your 2.4, Aiden. It's negative 2.4. Do you see that? Is that right? So if you made that negative, you should get 109.2. Good. Fixed it. Okay. So that is